He's been helping me with like implementing some of the stuff. But here we go, right? So what do? We take our evil attack phone, we attach to the BTS, so we have to get a full channel for this one. It goes all the way through to the back end, and it informs the HLR, right? Tells the HLR that the phone has now been switched off. When that happens, the SIM card is now no longer on the network. So any phone calls or SMS that comes in is going to go to the HLR and say, where do I route this incoming information? The HLR goes, you can't, he's not on the network, declined, right? Now, the beautiful thing about this is that the guy with the phone can still make phone calls and send SMS and see full signal, right? Because we're not interfering with any of that particular information. We're only telling the back end that he's been turned off. What Sylvain found out, actually, when he tested this himself, was that when you do the detach attack, when you inform the HLR that the phone has been switched off, it terminates any existing phone calls, right? So if you have this on a 30-second loop, just sending detach requests all the time, the guy will never be able to make a phone call that lasts more than 30 seconds, right? Like it'll immediately cut him off. So. No, it does not. It can, like, basically, because there's no security software in here at all to check for that information, right? Like, if they were intelligent, what they would do is they'd say, your last location update request came from Detroit. Now you're in, Atlanta saying that you've been turned off. I think you're full of shit, right? They don't do that, no.
If you just make a text message or a phone call after the session's been turned off, does it automatically update the database?
Yes. So the question is, like, when someone starts to make an SMS or a phone call, do they get automatically re-authenticated? And the way that the GSM network is implemented is yes, they do. Every time that they open a channel, they have to authenticate against the network, and that authentication is used to update the back-end information in the HLR. So if we combine this with like taking down all of the network or any other thing, like we could interfere with that. But as it stands right now, you can target one individual. So if you have their phone number, you can kick them off the network. So this demo is going to be fucking awesome. I was just going to take someone's phone number and then kick them off. But once again, yeah, it doesn't work. So if everyone could just imagine for a minute that their phone didn't work properly and you couldn't get phone calls, and it wasn't because you were on AT&T, it was deliberate action, right? Then yeah, we could do that. Right, so those cover the GSM client-based attacks that I've implemented so far. So there's only 3 of them, but I've only been doing this for about a month or so on the client side. Prior to this, what we were working on is doing fuzzing against mobile phones because we wanted to be able to own everyone that walks by our office. And so for that stuff, we were doing baseband fuzzing. So we were using a malicious BTS to send packets and try and fuzz the baseband of mobile phones. So everyone's familiar with how a smartphone is actually made up, right? It's literally 2 separate CPUs. Usually they share RAM, but basically you have a phone like this, a feature phone, that acts pretty much as a modem. All it does is connect to the network, handle the networking stack, and then it will have a channel that's open to an actual operating system. So, like, for example, one of these things or one of these, right? These have a separate chip running the operating system. From our fuzzing point of view, we weren't actually interested in the operating system. We wanted to go for the baseband because the baseband has basically no user interaction, right? There's no like, do you want to authenticate this? None of that happens. The baseband is all pretty much done without any interference from the user, right? They can't have any access to it. So yeah, like we don't care about that part. We only want the other part. Yeah, cool. The other awesome thing about going after the baseband is most of them are written in C, and they were written in like the 90s, right? Everyone remembers how awesome the code was in the 90s when everyone knew about like integer wraps and how you had to be very careful about like sideness issues and so on. Yeah, so like fuzzing these things is quite cool. There's some downsides. Actually, there's a lot of downsides. The biggest downside for us is that we have no visibility on the phone, I'll get to that in a minute, actually. I've got a whole slide on why it sucks to do this. So basically, all the baseband does is control the radio and run several stacks and like try and appear to be awesome to the user, whatever. They use a real-time operating system for the old versions of iOS up until 1 through 3. They used Nucleus OS. Now they use something called ReactX or React Thread. Jeru was telling me about it last night, but I was very drunk, so I don't remember. Anyway, okay, so basebands are the target that we're going after. The way that we've done this is we took OpenBTS, which is an open source project that uses the USRP, which is the Universal Software Radio Project, and we've modified it to allow third-party programs on the network to open a channel to a phone and send data. So we implemented over XML RPC is LCH open, LCH send, LCH receive, and LCH close. So we use the Bugmine framework, which is a framework developed by a friend of mine, Beng Nagy, my coworker, and we use his case generation tools and his mutation tools to generate the GSM attacks that we then send over XML RPC over OpenBTS through the USRP to the phone, right? And it's all done over Wi-Fi because I don't like wiring up my house. So it's fairly cool stuff. It's also very targeted because we use the IMSI to open a channel to a specific phone. There's some problems with the way it works because if we, everyone remembers from the RACH and the AGCH, it's all asynchronous. So we can inform a phone that it needs to open a channel, but we have no way of knowing that that channel has been opened until the phone authenticates to us, right? So we can see that a channel has been opened, but we don't know by which phone. So when we're fuzzing multiple phones, if we knock one of them over, we then get the channel request that we believed was for phone A will be for phone B when it shows up again. So that's a little bit annoying. Far more irritating is the fact that we have no visibility. We have no instrumentation, right? So all that happens is we make a phone reboot, and we detect this by using ping. You might have heard of it. It's a very sophisticated tool. It can monitor whether a phone is on a Wi-Fi network or not. And if it's not on the Wi-Fi network, we detect that the phone has crashed. And if it's crashed, we assume that it was some data we sent previously. And so it's very, very hard for us to go from fuzzing attacks, which we know make a phone reboot, to usable exploits that we can use to own people when they walk by. Which kind of sucks, because like, it would be really, really awesome to have a backpack that you could walk around and it would just own people simply by having them be within radio range. Right now in our fuzz farm, we've got, well, we don't have the iPhone and the BlackBerry because they're with me, but we have the Nexus 1, Palm Pre, Nokia N900, and we also have some MTK phones, but we're not particularly interested in those right now. Here's a picture of what it looks like. It's very sophisticated. It's very dark, actually. I don't think you can see it. There's a laptop and a USRP and a phone. Pretty awesome stuff.
Do all those phones use the same basebands or a common set of basebands?
No, typically what happens is basebands are purchased separately by, like, so HTC will go out and say, like, all right, we need a radio and it needs to do 3G and UMTS, and they'll find a commercial vendor who will sell them a baseband plus a radio, and then they just plug it in, right? Apple writes their own, BlackBerry writes their own, and Nokia writes their own. The Nokia one is called BB5. I'm not sure what the BlackBerry one is called. I've got some friends who have rim jobs around here, and they can answer. But like basically, people that care a lot write their own. Everyone else just buys a commercial version. They're not particularly sophisticated. Usually, like the Nokia interface is something called PhoneNet. It's now integrated into the Linux kernel. So there's a separate protocol based on sockets for talking to the baseband on a Nokia device. On the iPhone, the interface is basically the old Hayes modem, like ATD, 1, 2, 3, 4. Like that's how your iPhone talks to the radio. It treats it like a modem, right? Most phones actually act like that. It's the easiest way. It's a common interface. Here's a picture of some phones that have attached to our fuzzing. It's called the Cosic GSM Fuzz Farm. What would happen is when a phone associated with the BTS, they would get an SMS saying, "Welcome to Coasting Fuzz Farm." I was running this in my condo, and what happened was one day I came home, and when I got out of the elevator, I got an SMS saying, "Welcome to Coasting Fuzz Farm." So I had to run back, just pull out all the antennas, and I changed it. So the new message actually doesn't say this anymore. It says, like, get your best erotic ads at blah, blah, blah. That way they'll never know it's me, right? So yeah, that basically covers it. We've gone over like the fuzzing setup that we have, the fact that none of the bugs we find from that are any use to us, the different attacks that we can do from a phone to the network, some of which are quite cool, but none of which work over here. The primary takeaways from this is for a very long time, GSM security has been based on the idea that GSM is a walled garden. The only people who had access to it were people who could do very, very complex programming and had access to expensive equipment. Now there's a lot of open source stuff available, and you need a €5 phone. You can make your own cable for next to nothing, and you can start hacking GSM. So there's going to be a lot more issues with GSM going forward. There's a lot more people getting interested in it. The USRP stuff means that OpenBTS is allowing people to set up fake base stations, and they can do interception attacks, IMSI catchers, other stuff like that. So yeah, like GSM is basically fucked, which is why I'm now starting to look at how I can do attacks against 3G. So in the future, most of what we look to do is we want to do more fuzzing against GSM stacks, hopefully get some visibility by someone who's really good at hardware, getting JTAG onto one of these boards. And we want to look at 3G and start going after 3G soon. So a big thanks to the Osmocom BB guys and the OpenBTS guys, because I use their software extensively. And you've got 4 minutes for questions. Better ask them now, because I'm going to be drunk later. All right.